These are the 10.6 notes for Algebra 2. We're talking today about increasing and decreasing. So you've got this chart here that kind of gives you examples of what's increasing, what's constant, and what's decreasing. Increasing just means you are going uphill. So on this graph, it looks like you're going uphill from, let me change colors here, from right here, which is -5. All the way up till right here, which is -2. So each time we talk about from here to here, we're talking about the x numbers. All right, it's also going uphill from 1 all the way till 3. So from 1 to 3. And this is the notation we use. We use that less than x, less than symbol. All right, for decreasing, we're going to be going downhill. And so this little red section is where we're decreasing, which would be from this point, which is 3, all the way until this point, which is 5. So from 3 all the way to 5. Constant is when you have a flat section, and that would happen right here from -2 all the way till 1. So from -2, less than x, less than 1. All right, for the next part, we're going to have these segments. And so the function for segment 1 is decreasing. It's going downhill. And that looks like it's happening from this point right here, which is -8, all the way to this point right here, which is -4. So we'll always read your graphs from the left to the right, so -8 to 4. And then segment 2, the green part, it's increasing. It's going uphill from -4, that point, all the way to 3. -4 all the way to 3. And segment 3, going back downhill, so decreasing from 3 all the way until 7. On the back side, we'll need to write our own inequalities, so our own x's with the less than symbols. So for each graph, tell the intervals where the graph is increasing and the intervals where the graph is decreasing. So example number 3, we are increasing from this point all the way up to this point. So on our graph, that would be from 0 all the way to 4. So from 0 to 4. I write that as 0, less than, always less than, x, less than 4. We never have to worry about switching those around to greater than signs. And then it would be decreasing from 4 all the way down to 9. So 4 less than x less than 9. That's how we say from 4 to 9 mathematically. Right. Example number 4, increasing from here all the way to there. So again, look down at your x's. That is happening from 0 all the way to 3. 0 less than x less than 3. And then it goes downhill, decreases from 3 all the way down to 10. So from 3 to 10. Okay. Now, both of those graphs, if you notice, had points at the end of them. And the ones we're about to do are going to have arrows at the end of them. So they're a little bit different. When something has an arrow, it means it continues on forever. And forever in math, we use the infinity symbol. So we have a negative infinity, which means all the way to the left. And then we have positive infinity, which means all the way to the right. So anytime you see this arrow on the left-hand side, you're going to use a negative infinity. Anytime you see the arrow on the right-hand side, you're going to use a positive infinity. Let's try this problem here. Example number 5, where is this increasing? As I look at the graph, it increases from that point all the way till forever because the arrow keeps going. So that would be from 3 less than x less than all the way to infinity. It keeps on going. Because it has that arrow, it means it keeps going. Okay, well, then where is it decreasing? It's going to be decreasing from forever all the way until 3. So because you have that arrow on the left, you can say negative infinity. Put your symbols on, and all the way to 3. All right, let's do the next one. Increasing from here all the way up. So this right here represents that negative infinity because it's just going to keep going to the left, negative infinity, all the way till -1. And then decreases from -1 all the way till infinity. There we go.